Hello, and welcome to the VMware App Defense demonstration. This video is intended to provide a quick demo showing how VMware's new App Defense platform can securely protect your applications from an array of different malware types, including those designed to exploit zero-day vulnerabilities in your data center. Specifically, we'll focus on a recent ransomware strain called WannaCry, which made headlines due to the widespread havoc it wreaked across data centers worldwide. A quick note before we get started. WannaCry leveraged a vulnerability in SMB file shares called Eternal Blue, which, once disclosed, was since patched by Microsoft. However, in our demo environment, we'll be using an unpatched Windows server, which is not running any endpoint security software, thereby allowing the simulation of a zero-day attack. A quick summary of App Defense before we get started. The standard model for providing endpoint security today involves deploying software agents from any number of security vendors alongside the applications within the guest OS. App Defense takes an entirely different approach. Instead of using an in-guest agent, VMware leverages our unique position in the hypervisor to protect your applications. To draw an analogy of how this works, imagine the hypervisor, which is a software component already ubiquitously deployed across your server infrastructure, now serves as a sensor array for purposes of detecting anomalous behavior in your applications. It does this by monitoring application behavior and establishing a known good profile for both the applications and the OS. Ultimately, this approach allows you to implement a least privileged whitelisting model for your OS and application configuration, deployment, and connectivity. Any behaviors outside those that have been approved will generate alarms in the App Defense Management appliance, which can then coordinate with VMware's NSX platform to provide quarantining and remediation services. To set the stage for this test, I have a small data center environment I'll be using. In this environment, I have a handful of vSphere hosts deployed, and I have vCenter managing these hosts, and I have NSX deployed as well, alongside the App Defense Management appliance, which is configured to monitor and protect this environment. I've also deployed two Windows 2012 server VMs, which are connected to an NSX virtual network. The Windows 2012 Server 1 will be acting as my guinea pig VM. It does not have any endpoint security software running on it. Windows Firewall is disabled, and it is an unpatched VM. So I'm going to remote into this server during the demo. I've downloaded the WannaCry ransomware strain, so I'm actually going to execute it during the demo. So you'll see it infect the machine, but at the exact same time, the App Defense Management appliance will actually detect that infection and generate a handful of alarms to notify the security personnel of the infection. It will then immediately coordinate with NSX Manager to actually quarantine that VM and remove it from the network to ensure it doesn't infect any other Windows machines in my environment, which is actually what the WannaCry ransomware does. So let's go ahead and get started. Okay, so I have RDP'd into a Windows jump box in my demo environment. This Windows jump box gets me access to log into vCenter, to access NSX, and to also access the App Defense Management console as well. So let's start out by putting our virtualization admin or our vSphere admin hat on and take a quick look at our virtualized environment. So I've already logged into vCenter, as you can see. I'm going to click on Host and Clusters, and you can see there's a pretty small environment here. I basically have two clusters, this top one serving as my compute cluster with 3 ESXi hosts in it. And on these ESXi hosts, you'll notice there are two VMs, base W1201 and base W1202. These are the two Windows 2012 server VMs that I described earlier in the introductory slide. And the base W1201 VM is the one that I will be intentionally infecting. And I just want to point out very quickly that if you take a look at the VM, you can see that it's currently not a member of any security groups. And if I scroll down a little bit further, you'll see that there's no security tags applied to it. And if I were to log into NSX and just show you the distributed firewall rules, there are absolutely no firewall rules applied to this VM. So it has full open communication. Right now it is entirely unprotected. But though I do want to log into NSX to show you one thing, I just clicked on the NSX plugin. I'm going to click on the Firewall tab, and in here you can see that there is a firewall section called VMware DRX Quarantine Policy. So this is an automated quarantine policy that App Defense configures by default when you connect it to vCenter and when you connect it to NSX. And it basically has two rules associated with it called block all outgoing traffic and block all incoming traffic. And the source and the destination for those rules are the quarantine group. And if I were to click on this security group, you'll notice that there's no VMs right now that are a member of that security group. So right now nothing's quarantined, nothing's being blocked. Of course, that's because my environment's clean at this point. So with that out of the way, let's go ahead. We're going to take off our vSphere administration hat and put on our security admin hat. And we are going to log into the App Defense Management Console. So this is the main login screen here. You just input your credentials, and as we log in, you're going to see the main console come up with a number of widgets, primarily a dashboard here showing basically the inventory of my environment. You'll see I have 7 unassigned VMs, so these are VMs that are currently not being protected, but I do have these 2 VMs that are being protected, and they are part of a single scope, and I will explain what that means in just a minute here. You'll also notice there's a number of provisioning events, so it shows all the provisioning events involved in actually pulling these VMs into an application scope and getting them into a protected state. And very importantly here, you'll also notice that there is no alarms for this environment. So over here on the left, I have these scopes. So this is essentially where I define my applications, and I've done that here. I have a single scope defined that I'm calling Windows 2012 Active Directory and DNS servers. So I'm going to click on this, and then you can see that quick summary of the scope. There are 2 VMs that are a member of it. So here you'll see the same 2 VMs, base W1201 and base W1202, that it pulled from the vCenter inventory. And there are a number of rules defined. So we have rules to enforce outbound and inbound connections and enforce guest OS and host module integrity as well. And then there's a whole group of behaviors as well that are established as a baseline. So before these VMs were put into a protected state, we had them in a monitoring state for about a week, and during that time the App Defense Management Console monitored all the behaviors on the VM, all the processes that were running, all the connections that it established. And once it did that for a sufficient amount of time, we moved this scope into a protected state. And here's just a quick summary of all the processes that were running during the monitoring state. And you can see these processes have child connections or child threads as well. So if I were to click on service host, that's probably one of the larger ones with 22 child connections. You'll see there's a whole bunch of actual CLI commands that service host executes here. So there's an actual hash for the service host file, and here's some of the commands it runs. And we can actually even expand these further to see some of the outbound connections that it made. And all these are part of the manifest or the baseline known good behavior for this application. So with that in mind, we are going to take off our security admin hat and actually put on our user hat and take a quick look at the Windows 2012 1 and 2 VMs by themselves. So I've already remoted into these from vCenter, and you'll notice here in the system tray there's basically, there's basically nothing running. If it's going to allow me to click this, there's nothing running from an endpoint security software. About the only thing on this virtual machine besides standard Windows services is VMware tools. And I did a quick IP config to show you the IP address that's part of the 192.168.100 network, IP address being .100. And just to verify that we do have connectivity from this VM, I can ping the default gateway. So we'll take a quick look at the Windows 2012 #2 server. And this is also an unprotected, unpatched VM. It's not running any endpoint security software, and it's part of the same network, the 192.168.100 network. And I'm going to go ahead and just ping the Windows 2012 Server 1 VM just to validate I have connectivity on the local network, the NSX virtual network, to which both these two VMs are attached. Okay, so back to our Windows 2012 server, and we're going to actually go ahead and execute the malware. As I mentioned, I've downloaded the WannaCry malware locally on this machine here. So I'm going to go ahead and execute that and click on Run. And as I do that, you'll see a number of files that it actually unpacks, including this WannaDecryptor.exe. So that's the actual executable that's going to encrypt all the files on this Windows server here. And as this is done running, it just occurred, you'll see actually that it provides notification in the background indicating that the files on the machine are encrypted. If I were to actually take a look at the files here, I won't have access to them. And obviously this pop-up shows up as well, indicating how I can recover my files. So with that in mind, let's go ahead and take a look at the App Defense Management Console to see what it has detected and what actions it has taken in response to this event. So let's put our security admin hat back on and go back to the App Defense Management Console, and you can see here's our scope that we were looking at earlier, and there are 10 uncleared alarms that have been generated. So let's go ahead and go to the alarms section, and you can see these alarms are of a critical severity. They're part of the scope or the service that we previously defined and looked at, and this one is for an outbound connection rule violation. So if we click on that to drill down into it, you'll see that this process that looks like it might be legitimate, task hsvc.exe, generated this alarm. It's not an approved process or one that's part of the baseline behavior, and it was actually kicked off in this directory, and you can see that WannaCry actually installed Tor, which kicked off this process here. And there's 47 modules or 47 files and DLLs within that Windows server that the process touched or tried to manipulate, and you can click on any number of these DLL files, any number of these modules here to get additional information about that file and what sort of privileges it has and a description of it. Ultimately, you can see though that the process tried to make an unapproved outbound connection as well from this IP to this IP. So we obviously do not want to clear this alarm or allow this behavior. But with the generation of all these alarms, let's see actually what action was taken. So when these alarms occurred, the App Defense Management console for this scope is configured to quarantine the VM. So if we go back to vSphere and we click on the Windows 2012 Server 1 here, if you recall earlier, this VM was not part of any security group. And it did not have any security tags associated with it. Obviously that's changed here. What happened was App Defense made an API call to NSX Manager, added this vulnerability found tag, and the vulnerability found tag automatically made it a member of this security group, which was also pre-created by App Defense when I integrated it with NSX. And so if I was actually to go to the NSX Manager plugin and go back to the distributed firewall, we have that section of the distributed firewall created by App Defense called the quarantine policy, and the source and destination for the rules in this policy are the quarantine security group, of which previously there were no members. My base W1201 server, which has since been infected, is now a member of this security group, so it is effectively quarantined and removed from the network, so the malware cannot spread and infect any other machines in the network. So if I go back to my Windows 2012 02 VM, obviously it is clean, there's no infection here, and the ping that I was running to the server 1 VM is now timing out because it has been removed from the network. So that's it for this demo. I hope you found this useful, and if you have any further questions on app defense, please reach out to your VMware systems engineer or account manager. Thank you very much.